Have you ever looked up at the night sky and wondered about all that stuff out there? The vast expanse of space is not just an empty void. Beyond the twinkling stars, space is full of dust, dirt, and rocks. These tiny particles float around, seemingly insignificant. It might seem weird to think about, but this cosmic debris is important. These particles play a crucial role in the grand scheme of the universe. It helps us understand how planets form, and even where life might come from. The dust and rocks are the building blocks of planets, moons, and even life itself. So where does all this stuff come from? How did it get here? Let's explore the fascinating origins of these celestial building blocks. They come from the birth and death of stars, from the collisions of galaxies, and from the remnants of ancient cosmic events. You might be surprised to learn that some of the dust that settles in your house might have come from space. It's true. Every day, tiny particles from space land on Earth. Tiny particles from asteroids and comets constantly rain down on Earth. These particles are remnants of the early solar system, carrying with them the history of our cosmic neighborhood. But that's just a small part of the story. The universe is a dynamic place with constant activity and change. To understand the origins of space dust, dirt, and rocks, we need to look at the biggest explosions and most creative forces in the universe. Supernovae, the explosive deaths of stars, scatter elements across space, while galaxy collisions create new stars and planets. These processes are ongoing, constantly shaping and reshaping the universe. The dust and debris we see are the remnants of these cosmic events, telling the story of the universe's past and hinting at its future. Stars are like giant factories forging elements in their cores. These elements are created through the process of nuclear fusion, where lighter elements like hydrogen are fused together to form heavier elements such as helium, carbon, and oxygen. This process releases an immense amount of energy, which is why stars shine so brightly. When massive stars run out of fuel, they explode in spectacular events called supernovae. These explosions are among the most energetic events in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. These explosions are so powerful that they scatter newly formed elements, including those found in dust and rocks across vast distances of space. The force of the explosion propels these elements at incredible speeds, spreading them far and wide. Imagine a firework exploding and scattering colorful sparks across the night sky. Supernovae are similar. They create stunning displays of light and color, visible across vast distances in the cosmos. They fling out huge amounts of material like oxygen, which is essential for life as we know it. Silicon, which is a key component of rocks and sand, and iron, which is found in the cores of planets and in our own blood. These elements are the same ingredients that make up planets and even us. Without supernovae, the universe would lack the diversity of elements needed to form complex structures. These elements become part of giant clouds of gas and dust, providing the raw materials for the next generation of stars and planetary systems. Over time, gravity pulls these clouds together, forming new stars and planets, continuing the cycle of cosmic creation. Nebulae, those stunning clouds of gas and dust scattered throughout galaxies, are more than just pretty pictures. These cosmic clouds are stellar nurseries, the birthplaces of stars. Gravity draws the dust and gas together, and as more material clumps together, the center heats up. Eventually, a star ignites. The leftovers from this process, the dust and gas that didn't get incorporated into the star, swirl around it, forming a disk. This disk is where planets like our Earth are born. Tiny dust grains collide and stick together, growing bigger and bigger over millions of years. Think of how you might build a snowman. You start with a handful of snow, then roll it around to gather more. As it gets bigger, it attracts even more snow. Planet formation works in a similar way. In the swirling disk around a young star, dust grains collide and stick together, forming larger clumps called planetesimals. These planetesimals attract more and more material through gravity, pulling in dust, gas, and even other planetesimals. Over millions of years, these collisions and mergers create larger and larger objects. Eventually, some of these objects grow massive enough to become planets, while others remain as asteroids like giant space rocks. Section 5. Accretion, shaping worlds. As planets form and grow, their surfaces are constantly bombarded by leftover debris from the early solar system. This process, called accretion, plays a crucial role in shaping the landscapes of planets and moons. Think of it like cosmic sculpting. The moon, for example, is covered in craters of all sizes, evidence of a violent past. Earth has experienced countless impacts as well, but our planet's active geology has erased most of the evidence. These impacts deliver new materials to planets, contributing to their diversity. Section 6. Cosmic Wanderers, Asteroids, and Comets. Asteroids, rocky remnants from the early solar system, are like time capsules from the birth of our planets. They provide valuable clues about the conditions and materials present during that era. Comets, on the other hand, are like dirty snowballs, made of ice, dust, and rock. As comets approach the sun, their ice vaporizes, creating those spectacular tails we see streaking across the sky. These icy bodies are thought to have delivered water and other essential ingredients for life to early Earth. Section 7. Unlocking the secrets of space rocks. Studying space dust, rocks, and other objects is like piecing together a giant cosmic puzzle. By analyzing their composition, we can learn about the history of our solar system, the formation of planets, and even the conditions that led to the emergence of life. Spacecraft missions, like NASA's OSIRIS-REx, have visited asteroids and brought back samples to Earth for detailed study. These samples are incredibly valuable, providing a glimpse into the building blocks of our solar system and the processes that shaped it. Section 8. The Endless Frontier. As we continue to explore the cosmos, we embark on a journey that stretches the limits of our imagination and technology. We'll undoubtedly encounter even more intriguing examples of space dust, dirt, and rocks, each with its own story to tell. These celestial remnants hold clues to the origins of our solar system, offering a glimpse into the processes that shaped our cosmic neighborhood. They also hint at the possibilities for life beyond Earth, suggesting that we may not be alone in this vast expanse. Each discovery brings us closer to understanding our place in the grand tapestry of the universe, connecting the dots of our cosmic heritage. So, the next time you see a shooting star, remember that it's more than just a fleeting moment of beauty. When you gaze up at the Milky Way, you're looking at a galaxy teeming with billions of stars, each with its own potential for planets and life. Remember that you're witnessing the remnants of stellar explosions, the dramatic end of a star's life cycle. These explosions scatter the building blocks of planets across the cosmos, seeding new worlds with the elements necessary for life. The universe is a vast and wondrous place, filled with mysteries waiting to be uncovered and stories waiting to be told. Its tiniest particles hold the keys to unlocking its greatest mysteries, revealing the secrets of creation and the potential for future discoveries.